Well, hello everyone. Yes, we are live now. Welcome to Weekly Review Live. This currently it's November 21st, and this video is for November 17th, rather, through the 21st. All right, let's see what we got going on this week. I got my usual notes here. So we wrapped up Unit 6, which was all about electrons in the atoms. By the way, as always, I should mention it's kind of, you know it now. I'm a little scatterbrained, but thank you for tuning in. If you're watching, if you have any questions, if you're watching this live, please feel free to throw a tweet out to @WindsorChem, or if you want, you can text in to 607-205-8577, and that'll show up, and I can do my best to answer your questions. So feel free to let me know if anything's going on. But like I said, we wrapped up Unit 6 this week, and that was all about electrons in the atom. And it started this week. We wrapped up the 4 labs that we did. We brought a conclusion question to that. And then we talked about ions, which was video 4.2 on Google Drive. See, this way you can go back and look at it later. But that was a bit of a review from Unit 4, hence 4.2. And the deal was we looked at how many protons, neutrons, and electrons an atom has. Remember, the protons are always the same as the atomic number, which is the bottom number on the periodic table, the bottom bold-faced number. The atomic mass, which is the top number, that's equal to the number of protons and neutrons together. So the protons are from the atomic number. The neutrons you get by taking the difference of the mass and the atomic number. The electrons is all based on charge. If it's neutral, the protons and the electrons will be the same. If it has a charge, you have to reflect that with the number of electrons. Remember, positive charge means you have less electrons than protons, and because you have more positive. And a negative charge means you have more electrons than you have protons, hence the negative charge. The number tells you how many you're different by. So again, go check out video 4.2 for that. It's kind of tough for me to do examples running on the backup computer here. I can't bring up the iPad, so sorry. But 4.2 has some examples. Go check that out. That was ions. From there, we went on to talk about Lewis dot structures, which was video 6.5 in the Google Drive. Now, Lewis dot structures are a simple way of showing atoms. We said that you always have the symbol in the center, and then the electrons go around it. But it's just the valence electrons, just the outermost electrons. So when you're looking at a periodic table, like this one, maybe that's like with iron, the valence electrons, it has 2 valence electrons because it's always the last number in the electron configuration. Something over here like chlorine right here has 7 valence electrons because it has 7 is the last number. So whoops, I lost my thing here. Let's bring those back. What happened? I don't know why that preset disappears. That kind of bugs me. Put it back. Put it back. Well. Anyway, that stinks. So anyway, here I am. Again, if you have any questions, tweet them over to @WindsorChem, and we'll go from there. Or you can text questions rather to 607-205-8577. But Lewis dot structures, the symbol goes in the center. It only shows the valence electrons, and the first 2 electrons always have to go together. It doesn't matter if they're on the top, the bottom, the left side, or the right side. That doesn't matter. But the first 2 have to go together, and then you have to go and put 1 around each side and then go back and pair. Again, 6.5 tells you all about this and gives you some sample problems. And you had some homework on that. It was homework page 3. But that wrapped up Unit 6. Outstanding. From there, you had the Unit 6 quiz. And if you missed that, please come take that before we leave for Thanksgiving break. So again, if you missed the Unit 6 quiz in class, please come down during a free mod or lunch or before or after school, Monday or Tuesday, to wrap that up. Hopefully you came and saw me about it today, but if not, see me Monday or Tuesday. Then we started Unit 7. Unit 7 was all about the periodic table. This thing. So we had some interesting talks about the periodic table and all that good stuff. And it started with video 7.1, which was the basics of the periodic table. Video 7.1. A lot of it we already talked about, so we can review quickly. When you're looking at the periodic table, You got the, yeah, I'm over here. Hi. You got the zigzag line, the staircase that goes down, you know, down there. And on the left side of the table, we have metals. On the right side of the table, we have non-metals. And on the staircase, we have the semi-metals, except for aluminum and polonium. Some other things we talked about, well, let's just do this. Group 1, oh, hang on, I gotta have my special little thing here. Group 1 has, let me see, oh, that has the special name of the alkali metals. There we go. Group 2 has the special has the special name of the alkaline earth metals. Sorry, Mr. V over in physics just sent me a really funny text. So group 1 is the alkali metals. Group 2 are the alkaline earth metals. The valley groups 3 through 12 are called the transition metals. Remember, they don't follow the same rules as everybody else. And then the other ones that had special name was group 17, which are the halogens, and group 18, which are the noble gases. So that was kind of the basics of the periodic table. And there's some other things in there that we talked about. Life is great. From there, we went on to talk about atomic radius, 7.2 in Google Drive. Now, as far as what happens with the atomic radius, you should never get that wrong because you can always look it up. Pick something that's on the left side of the table, pick something that's on the right side of the table in the same period, excluding all the noble gases, and then look them up on table S. Look up their radius and see what happens. You'll notice as you move across a period from left to right, they get smaller. The atoms get smaller and smaller and smaller. We said that's because of an increased nuclear charge. What that means is there's more protons in the nucleus, giving it more charge. More protons lets it pull those rings in tighter. Because again, you're adding electrons, but they're always on the same ring. Because there's more protons, it pulls everything in tighter. So as you move from left to right across a period, the atomic radius decreases because of an increase in nuclear charge. The easier one was as you move down a group. As you move down a group, the atom gets bigger and bigger and bigger. There's the bell. It gets bigger and bigger and bigger, and that's because you're adding more principal energy levels. Some people like to say it's because you're adding more electrons. That's not necessarily true because I'm adding more electrons as I move to the right. But as I move down, I'm adding more levels. It's more specific. So again, from left to right, the radius decreases because of an increased nuclear charge. And as you move from top to the bottom of a group, the radius increases because of increased number of principal energy levels. So that is video 7.2. Then we ended with some of us got to video 7.3. Not everybody. That was about ionic radii. And what's important to keep in mind with that is that, I can't do that anymore. What's important to keep in mind with that is, here, we'll try this. There we go. Everything's trying to get a full outer shell. And for most elements, that means they want 8 valence electrons. The first 5 elements only want 2 valence electrons because that's all that can fit in the first level. But most elements are looking to get 8, a full outer shell, which typically means 8. So you have to look at an element and say, well, what's it going to do? We said group 1 has 1 valence electron. Well, to get to 8, it can either gain 7 or lose 1. We said it's easier to lose 1 than it is to gain 7, so it loses electrons. Over in group 17, they have 7 valence electrons. They can either gain 1 or lose 7. Again, gaining 1 is easier. Nature is lazy. We're also going to say later that nature is lazy and crazy, but for right now, we'll focus on the nature is lazy. It wants to do the least amount of work possible. So that's always what it comes down to. Now, we said an atom is just like your wallet. If your wallet gains money, it's going to get bigger. The same is true for atoms. When they gain electrons, they're going to get more negative, and their charge, right? Their charge will get more negative, and they're going to get bigger. When an atom loses electrons, just like when your wallet loses money, your wallet gets smaller. When an atom loses electrons, it's going to get more positive, which is a little confusing. If I get rid of negative things, I'll become more positive. Think about it. If you got a lot of crap happening in your life, if you got a lot of negative things, if you get rid of those negative things, you are happier. You are more positive. So when an atom loses electrons, it becomes more positive and it gets smaller because it loses that level. Again, that's all explained on video 7.3. Some of the classes talked about that, some didn't. So if you didn't talk about it, we'll be talking about it Monday. If you did and you need a little extra help, go check out video 7.3. So there you have it. That is the week in review. So some reminders I have here. First off, the parent letter, the signed parent letter, and the marking period 1 survey. Those are both due by Tuesday before we leave on vacation. The Unit 6 quiz that we took in class, if you missed that, please come see me again either Monday or Tuesday before we leave for vacation so you can take that quiz. After that, we're going to have to figure something else out, and it's not going to be good for either of us. So come see me Monday or Tuesday to take that. I have here that the 3 weeks ends Thursday, December 4th. Now that may sound a ways off because it's December, but that's the Thursday we get back from break. 3 weeks is already over the Thursday we come back from break. That's cocoa nuts. So check out eSchool, see if you got anything missing. Make sure you get that taken care of because it has to be in by Thursday, December 4th. Lab 8 and Lab 10, that was the Energy and Photons lab and 8 and 10 was the Lifesaver lab and the Flame Test lab. Those makeups will be after school on Wednesday, December 3rd. Lab 9, which was the Energy and Photons lab, that makeup will be after school Wednesday, December 10th. And then Lab 11, which was the Emission Spectroscopy lab, will be made up after school on Wednesday, December 17th. If you forgot that, if you forgot when marking period 3 is, when the lab makeups are, anything like that, go check out the website. Everything is there. In fact, let's see if we can go do that now. So let's see, let's do a screen share. We're going to go over here, and now we're going to open up a new tab because that's how I keep track on you with Twitter. And we're going to go to, let's do Windsor. Yep, there it was. Not Mr. Bretchko. We don't want that. And you can go to my page. I don't have it bookmarked because I don't use Safari. I use Chrome, but whatever. So again, with the website, you got the video, you got everything's cool. Down here is the calendar. You can import that calendar right here, and that'll let it show up in your mobile device, in your computer, whatever you want it to show up in. That way, you can have all these things show up in your mobile device. You don't have to come here to look at it. But this calendar tells you everything you need to know. So again, end of 3 weeks right here on the 4th of December. If we go to December, it says the lab makeup right here, 8 and 10, boop, on the 3rd. Lab makeup for number 9, boop, on the 10th. Lab makeup for number 11, boop, on the 17th. So those are all there for you, along with when 6 weeks ends, when the marking period ends, when 3 weeks, 6 weeks, vacations, marking periods, everything, even down to your Common Core exams. The last call for late labs, we'll be talking about that soon. Your U.S. history regions, your chemistry regions, everything is there. Holy crap. What a wonderful place to find all the information that you need. So maybe you should check that out. Right? So also you can check out YouTube for helpful videos on this stuff and other units. They're in Google Drive. You can check it out on Google Drive. You can check it out on YouTube. So there's tons of information out there, especially now when we start getting into new stuff, it can get a little tricky. So that's the end of my reminders on my list. That means it's the end of the show. Thank you for tuning in. I had a wonderful week. I hope you had a good week. I have a great weekend. I'll see you for the short week next week, and then it's off to Thanksgiving. All right, have a great weekend. I'll see you all later. Bye-bye.